Welcome to the fastest way to learn data structures and algorithms with this premium revision material. Today, we are mastering LeetCode 153. Find minimum in rotated sorted array. This is a fundamental binary search challenge that tests your ability to navigate shifted data efficiently. Let us look at the problem statement. We are given an array of length n that was originally sorted in ascending order, but then rotated between 1 and n times. Our goal is to find the minimum element in this array in O of log n time. This means a simple linear scan is out of the question. We must use the sorted nature of the array, even if it has been shifted. Think of it like a mountain range that has been sliced and shifted. Imagine a steady uphill climb that suddenly drops off a cliff, before starting to climb again. To find the lowest point of this entire range, you do not need to walk every single step. Instead, you can look at where you are, and compare it to the very end of the range. If your current height is higher than the end, you know the drop-off point, the lowest point, must be somewhere ahead of you. If you are already lower than the end, then you have already passed the drop-off, and the lowest point is behind you or right where you stand. Our strategy is binary search. We maintain two pointers, left and right. In every step, we calculate the middle element. The key insight is comparing middle with right. If middle is greater than right, it means the rotation point and thus the minimum element must be in the right half. So, we move left to middle plus 1. Otherwise, if middle is less than or equal to right, the minimum could be middle itself, or something to its left. So, we move right to middle. We continue this until left and right meet at the minimum element. Let us dive into the dry run. Look at the screen. We have our input array 4, 5, 6, 7, 0, 1, 2. We initialize left at index 0, and right at index 6. Iteration 1. Left is 4. Right is 2. Our middle is at index 3, which is 7. We compare middle 7 with right 2. Since 7 is greater than 2, the minimum must be in the right half. We move left to index 4, which is 0. Iteration 2. Left is 0. Right is 2. Our middle is at index 5, which is 1. We compare middle 1 with right 2. Since 1 is less than 2, the minimum could be middle or to the left. We move right to index 5. Iteration 3. Left is 0. Right is 1. Our middle is at index 4, which is 0. We compare middle 0 with right 1. Since 0 is less than 1, we move right to index 4. Now, left and right both point to index 4, which is 0. We found it. The minimum is 0. Now, let us look at the Python code. We start by initializing left and right at the boundaries of the array. We use a while loop that runs as long as left is less than right. Inside, we calculate mid using the floor division of left plus right. The core logic is our if statement, comparing nums at mid with nums at right. If nums at mid is greater, we search the right half by setting left to mid plus 1. Otherwise, we narrow the search to the left half, including mid, by setting right to mid. Finally, we return nums at left, which will be the minimum element. Looking at the complexity, the time complexity is O of log n, where n is the number of elements, because we have the search space in each step. The space complexity is O of 1, as we only use a few pointer variables. And that is the find minimum and rotated sorted array challenge mastered. Save this video for your next technical interview, and follow Leo Academy for more such premium DSA guides.